Hello, in this video we're going to learn how to draw the VSEPR structure for selenium tetrafluoride. First we need the Lewis dot structure. We have selenium, we have fluorine. Selenium is going to give me 6 valence electrons. Fluorine is going to give me 7 valence electrons. If we do our total, we are going to have 1 selenium giving us those 6 electrons plus 4 fluorines, each giving us 7 electrons. We have 28 plus 6, 34 valence electrons to work with. Fluorine's always a terminal atom, so we need to place selenium in the center. We'll put our fluorines in a spoked wagon type arrangement around there. We had 34 electrons to work with. We just made 4 bonds of bonds. Each of those required 2 electrons. 34 minus 8 is going to be 26 electrons left. We'll start filling out the octets on our terminal atoms here. We had 26 electrons. We just burned 6 times 4. 4 times 6 electrons. We are left with 2 electrons left over. They have to go on this central atom here. We can fill in our bond dipoles. Fluorine's the most electronegative atom. All bond dipoles always point towards fluorine. We can calculate our steric number. It's going to be the number of lone pairs plus the number of atoms the central atom is attached to. So this atom is attached to 1, 2, 3, 4 atoms and has a lone pair for a total steric number of 5. We need the lone pair number. That's just going to be the number of lone pairs on the central atom. He's only got 1, so that's a 1. We come down to our chart. We go to the steric number of 5. We want to come over to the column for 1 lone pair. And this is what we got here. Sawhorse or seesaw. I never call it sawhorse. I always call it seesaw. This is kind of a funny little structure here. It's very key that this electron is being placed in this equatorial position here. If we come back up, we need to interpret that for our scenario here. That means I'm going to have selenium in the center. I'm going to have fluorine up here. I'm going to have fluorine down here. I'm going to have that lone pair over here. Going into the board, I'm going to have a fluorine. And coming out at you, I'm going to have a fluorine. And then I fill in their lone pairs. The electron geometry is always the same as the first column for that steric number, so it's going to be trigonal bipyramidal. And the molecular geometry is called seesaw.